Today on How It's Made. Tequila, one of the best shots at lifting your spirits. Waterbeds, there are no wet blankets on this undercover inspection. Flip-flops, putting the art and soul into footwear. And silver, the most conductive metal, bar none. But first, the origins of tequila can be traced back many centuries. Mexico's Aztecs fermented the juice of the agave plant to produce a low-alcohol drink called pulque. When the Spanish conquistadors arrived, they added distillation to the process for a much stronger drink, and tequila was born. Pass the salt and lime. Tequila is to Mexico as champagne is to France. Tequila is only made in this part of the world, and Mexico has claimed exclusive rights to the word tequila. For centuries, workers called jimadores have grown and harvested the agave plant for tequila. It takes 7 years on average for a species called Weber blue agave to mature. Even today, it's harvested entirely by hand, using a razor-sharp hoe-like tool. The jimadores chop away the greenery until all that's left is a huge core called the pina. Filing the round blade frequently keeps it sharp, allowing them to remove most of the bitter-tasting leaves from the pina. The tequila distilled from this crop will be a premium grade, made from 100% agave juice. The jimadores routinely remove a small piece and measure the starch content of the crop. Only if it's deemed to be sufficient is the agave pina sent to the distillery. Workers wield special hatchets to carve the huge pinas into quarters to make them more manageable for baking. They transfer the chopped pina to a brick oven, where it's steam-baked for 79 hours. This thorough cooking converts the agave starch to sugar. In the process, the flesh softens and the colour turns from white to reddish-brown. The baked agave pina now spills onto a shredder that rotates to tear the fruit into long, thin fibres. These fibres exit onto a conveyor. The shredded pina lands in a pit, where a worker forks it up and moves it into the path of a huge stone wheel called a tahona. Operated mechanically, the tahona wheel turns to crush the fibres and squeeze out the precious agave nectar. It takes 2 hours of crushing to extract all the juices. They pipe the juicy mash into wooden tanks and add yeast. The yeast causes fermentation, a process where sugar is transformed into alcohol. After 72 hours of fermentation, the alcohol content reaches 5%. The fermented pulp and juices have an earthy, acidic bouquet, and the aroma fills the air. They transfer the fermented mash to small copper stills. Inside the stills, the alcohol is boiled off and the vapor condensed into a more potent liquid. This is called distillation. After 2 distillation cycles, they have tequila. A technician measures the alcohol content and it's 55%. After straining out the pulp, they transfer the tequila to steel tanks. They add purified well water to dilute the alcohol content and bring it down to 40%. The tequila is now ready to drink, so it's over to the bottling line. With the bottles upside down on a revolving carousel, they spray the inside with tequila for a quick rinse. The grippers flip them right side up so they can be filled. This automated system maintains a precise filling level. An employee corks the bottles and then sends them down the line. The next worker presses adhesive-backed transparent labels onto them. The see-through labels showcase the clarity of this fresh, premium tequila. For a drink with a little more complexity, they aged the tequila in oak casks for 2 months or more, depending on the grade. During aging, the tequila takes on a woody flavour and turns a warm shade of amber. master distiller personally approves every batch. He checks the colour, inhales the aroma, and puts his observations down on paper. He also takes a little sip. No longer just a rough swig for banditos, tequila has gone up market and is a key ingredient in many popular cocktails. The end result is still the same though. Cheers. Waterbeds have come a long way since the ancient Persians slept on water-filled goat skins. They became fashionable in the late 1960s. However, early models were pretty wavy and made some people seasick. Innovative changes in design have made today's waterbeds as stable as a traditional mattress. Water doesn't compress, it displaces. That's why a waterbed mattress shapes to your body, giving you equal support everywhere with no pressure points. A washable quilted cover sits on top of the mattress to provide extra cushioning and absorb perspiration. The mattress is made of highly durable vinyl. It arrives at the waterbed factory in giant rolls, which workers feed into a conditioning machine. At a speed of 1 meter per minute, the machine heats the vinyl to 38 degrees Celsius. This pre-shrinks the material, ensuring the mattress won't contract over time. Next, computer-guided machines cut out the mattress's top and bottom. Die cutters stamp out the smaller and simpler corner and valve segments. Then workers lay the top piece on a wooden pattern mold. Applying this pattern makes the vinyl more flexible, helping the mattress to follow the form of the body. The company won't reveal exactly how this caged device molds the pattern into the vinyl. Now, with a die, workers cut a hole in the top piece for the fill valve. After fitting the valve and cap to a piece of vinyl printed with product information, they lay on the top piece, then fuse the vinyl with a high-frequency welder. It emits high-frequency electromagnetic waves, which heat and cause the molecules to interact, blending the two pieces seamlessly into one. Next, the corners of the mattress. This is the most complex part of the process because it requires making a very particular angle. After fusing the folds with the high-frequency welder, they slip each corner onto a rounded form, then close off the tip by welding on a circle of vinyl. This makes a rounded corner, which is far more durable than a pointed one. Whilst regular mattresses are foam-filled, waterbed mattresses contain fibre, which makes the bed waveless. Mattresses come in various degrees of stability. The more layers of fibre inside, the less the mattress moves. Once they've inserted the fibre, workers perform a final round of high-frequency welding to close up the mattress. First, they position an aluminium stick under the area they have to weld. A static laser line shows workers where to position the mattress in the automatic welder. Once the mattress is welded all around, they remove the stick through the valve hole, then flatten the mattress, distributing the fibre evenly within it. The final operation is a quality control check. They put the mattress in a press and with a vacuum hose, extract all the air. Then they set the mattress aside for 6 hours to ensure no air seeps back in. This would indicate a leak. Elsewhere in the factory, they construct the frame in which the mattress sits. The lower part is made of PVC plastic. Workers fuse the frame parts with regular welding, melting, then pressing together the edges to bond them. This factory doesn't mass produce. Every single waterbed is made to order. The customer who ordered this one requested a frame upholstered in black faux leather. Nice. The mattress sits on a thick melamine base. They slot it into the frame, then secure it with screws. The upper sides of the frame are made of upholstered foam, designed to be soft against the back of your legs when you sit on the side of the bed. Waterbed mattresses are shipped empty. The installer fills it with water at the customer's home, leaving enough space inside for the water to displace under pressure. So even if the valve is open, water doesn't spill out, even when someone's lying down. So, there's no excuse if you do actually wet the bed. Coming up, flip-flops, fitting footwear for beach bums. And silver, making the grade in industry. See you after the break. They may not be the fanciest of footwear, but flip-flops are cheap and perfect for the beach. It's believed that these flat sandals, with the Y-shaped strap, are modelled after traditional Japanese sandals that have a wooden sole and a Y-strap woven from plant fibres. The anatomy of a flip-flop is pretty basic. A sole and Y-shaped straps called uppers. The sole has two parts, a top and a bottom. They make the bottom out of either heat-moulded plastic or rubber. A machine injects the molten material into passing moulds. Two fans positioned over the injector kickstart the cooling process. Then a continuous water cooling system takes over. 3.5 minutes after injection, the material is solid. They make the top soles from 8.5mm thick rubber sheets. A hydraulic press forces a sole-shaped die through the sheet, like a biscuit cutter slicing through dough. The die also cuts a hole and two slits for attaching the uppers. Some flip-flops have decorations on the top soles. The design is applied on each pair manually, using a standard screen printing process. The factory prepares a screen for each colour of the design. The screen is like a stencil, open mesh in the shape of the design, and the rest of the mesh is blocked. Workers load a pair of soles in each station of a rotary screen printing machine. Then they mount the screens. They close the first screen over the pair of soles. Then with a squeegee, spread ink across the screen surface. The ink passes through the open mesh, applying the design. They move the soles to the next screen and do the same with the second colour of ink, and so on. Now for the uppers. For this flip-flop style, they glue ribbon onto cotton tape. Once they've correctly positioned the ribbon, they stitch it in place. Then they connect the left side and the right side straps with masking tape. They add a toe piece. Then stitch everything together. And sew a cover piece over the toe piece. Uppers give the flip-flops different styles by using a variety of materials, colours, thicknesses and embellishments. The design possibilities are endless. Now to connect the uppers to the top sole, workers insert the toe piece into the toe hole and a strap end into each slit. They apply glue. Trim the ends. Then insert a last, a foot form in the required shoe size. They pull the straps tightly against it. Next, they coat the bottom of the top sole and the top of the bottom sole with glue. Then a quick trip through an oven activates the adhesive. Workers then place the bottom sole on a positioning guide and stick the top sole onto it, locking the strap ends in between. This is instant contact glue, so they have just one chance to get the alignment right. A 4-second bonding experience in a press, and they're soulmates. However, the bottom sole is slightly larger than the former top sole. So with a high-speed sander, workers trim off the excess, leaving the edge even and smooth. After a manual sanding, if necessary, and a thorough quality control inspection, the flip-flops are ready for packaging. Workers stuff a wad of paper under the uppers to prop them up, should the bag get squashed during transport. So, if you want to show off your feet on the beach, and you're a dedicated follower of fashion, a flip-flop could be the perfect way to toe the line. Surprisingly, jewellery and silverware are not its main uses, because 80% of the world's silver is actually mined for industrial purposes. Silver is the most conductive and reflective metal on the planet, so for example it's used in electronic components and in construction as an insulation coating on glass. This mining company produces silver bars, the composition of which is 93 to 97% pure silver. It sells the bars to a refinery, which further purifies them for sale to industry. The action begins down in the mine, where geologists point a Niton gun at various spots in the rock face. The device detects the levels of 40 different elements, including silver. Silver in its natural state isn't silver-coloured at all, it's charcoal grey. Those silver-looking deposits are actually zinc and lead. Miners drill holes in the silver-rich areas the geologist pinpointed, then insert sticks of dynamite. After the blast, carts haul the chunks of rock, called ore, to the surface. Geologists then test the piles of ore and blend them to achieve a consistent amount of silver content per kilogram of ore. The ore first goes into the primary crusher. The machine's huge steel teeth break up the chunks into smaller pieces. Those pieces then drop through the grates below into the secondary crusher, which breaks them down into even smaller pieces. Those go into vibrating cone crushers, which pulverize them into tiny pieces. A conveyor transports the crushed ore to the ball mill. At this point, the ore pieces are roughly 6 millimeters big. As the mill's large cylinders rotate, steel balls bounce around inside, grinding the ore into a powder. A water circulation system flushes the silver-rich powder out of the cylinder and into large tanks which keep the water moving. To separate and dissolve the metals in the powder, workers pour in acid. After 72 hours, the rock waste has settled at the bottom, and the solution containing dissolved silver is pumped through filter presses. The filter plates are treated with a zinc-based chemical which attracts silver molecules. As the solution passes through, the plates trap particles containing silver, forming a layer of black powder called silver precipitate, which is approximately 50% silver and 50% waste. To separate the silver from the waste, they first dry the precipitate in a gas furnace for a couple of hours. In the mining company's lab, technicians continually test ore samples to determine the grade, the term for the quality of silver per kilogram of ore. They heat the samples to 1093 degrees Celsius for about an hour to burn off the impurities. What's left after the burn-off are the silver and other metals, such as lead, zinc, copper, selenium and cadmium. Lab technicians then treat the samples with a chemical that prevents silver from burning off and put them back in the oven. When the samples come out, about an hour later, all the other metals have burnt off and only silver is left. They weigh the silver and compare it to the weight of the original sample in order to calculate the grade. Once satisfied with the grade, the batch is approved and the process can continue on an industrial scale. So back at the mill, workers put the dried silver precipitate into an oven, along with the chemicals that prevent the silver from burning off. Approximately 4 hours later, the silver and waste have separated and melted. Workers pour them into bar-shaped moulds. The silver is heavier and settles at the bottom. Workers skim off the waste, floating on top. In less than 5 minutes, the molten silver cools and hardens, and workers extract what is now a silver bar. The mining company sells the bars to a refinery for processing. So digging for dirt really can have a silver lining.
The men charged with protecting JFK on that fateful day in Dallas return to the scene of his assassination tonight on Discovery. Don't miss gut-wrenching and heartbreaking stories from the Kennedy detail at 9.